Now we completed the fundamentals of Lean Six Sigma and the foundation of quality theory, so it's time for us to do a project. Let's consider the problem statement. An oil change depot, Cool Oil Change, would like to increase productivity and increase the number of cars that can be serviced by the depot. Management decided to analyze a depot with one oil change station as a pilot project. The depot has Mr. Manager, Mr. Supervisor, and Mr. Oilman. The steering committee is head of office Mr. Boss and Mr. Manager. Mr. Lean is the project manager and Lean Six Sigma expert, and Mr. Data is the person who is responsible for data collection. The duration of project is estimated to be 2 weeks, and the budget is $15,700 or $196.26 per hour. So the project plan is number 1. Review the problem statement. Then prepare the project charter, including budget and milestones. Get the sign-off on the project. Then prepare project plan and schedule, and use the DMAIC framework, create work breakdown structure, project schedule, assign cost and resources. Prepare flow diagram and PMBOK, collect data and do statistical analysis. The statistical analysis will consist of Pareto distribution analysis. And at the end of the project, we'll make recommendations, create a mind map, and effort impact matrix. Let's create a project plan using the DMAIC framework. Define phase will include a project charter, project plan, work breakdown structure, schedule and critical path, and risks and RACI matrix. Measure phase will include collecting data and measuring oil change cycle time. We're not going to use the next tools in the project example, but if it were a real project, we'd definitely need them. Those tools are PMBOK and a checklist. In analysis phase, we will use the following tools. Analysis using descriptive statistics, PMBOK, process flow, and define types of waste. Once again, if it were a real project, would also include tree diagram, use 5 whys, fishbone diagram, brainstorming, and spaghetti diagram. In the improve phase, we will provide list of recommendations and effort impact matrix. Additional tools that would be included in the real projects are brainstorming, mind mapping, Scamper 7 hours. The last phase is the control phase, and that will include manager and supervisor to control the process, sign off on results, and close the project. And the additional tools are FMEA forms and control plan. Now it's time to fill up project charter template. We'll start with the project name, company, and the client's name. Next, we will provide the summary of what is in and out of scope. In this example project, the scope will include analysis of oil change process at one location, collecting data, and process improvements. And the out-of-scope item is modification and implementation of changes. After all, it's just an example project, so it will be very hard to demonstrate real implementation. Next, we'll list the deliverables, and they are process analysis and recommendations. Scope validation for us will be signing off on the project charter and accepting recommendations. Next list items is team resources, including Mr. Boss, Mr. Manager, Mr. Supervisor, Mr. Data, and Oilman. Key milestones are delivery of a project plan in 3 days after the project start, collecting data in 7 days after the project start, delivery of recommendations 14 days after the project start. The budget for this project is estimated at $15,700. Next, we will summarize risks and risk mitigation strategies. As an example, to mitigate schedule risk, we will add 2 contingency days. I will not read out the entire table. Please download the project and review the risk table. Finally, we'll need to summarize accountabilities and responsibilities in the form of RACI matrix that is displayed on the screen and also available in downloads. Project plan will be usually done in line with PMBOK recommendations. PMBOK stands for Project Management Book of Knowledge. Since it's not a project management course, we will not be going through each and every process and generate the detailed plan, but we will create a schedule and work breakdown structure. If you're interested in learning about project management, please check our website hksmnow.com. Also, you can find links to many more courses in the last section of this course. Work breakdown structure, or WBS, is a method of taking scope and breaking it down into smaller, manageable work packages, and then into activities for scheduling. This is just an example, and we will use Excel to build our work breakdown structure and schedule. However, if you're working on large and complex projects, you should explore Microsoft Project or any other scheduling software. For the project example, I list the activities on the left, and the activities are aligned with the project plan. And as you can see, I use red font to highlight critical path. If you are using professional scheduling tool software, it will calculate and highlight critical path for you. Critical path is the longest path from start to finish of the project. It indicates the minimum amount of time that is necessary to complete the project, and any delay along the critical path will delay the entire project. Note that each activity has a resource name and cost assigned to it. In this example, I used average billing rate to estimate the cost, but more often than not, you will have to use an assigned cost of each resource. If you use Microsoft Project, it will do the math for you. I summarize process steps on this page. I think it's the best if we will go and review it together. However, I should say that the first document that I created is just listing the steps, and then I build the flow diagram. The process starts by a customer checking in, a supervisor filling up check-in form, and sending the form to the manager. If we can start servicing a car, the customer drives in a dock, and a copy of the form is sent to the tech. Once the car is in the dock, the supervisor checks the mileage and the odometer, checks the tire pressure, lights, and loops the hinges. When technician is available to start work, the technician will check the oil type, get his tools, remove the cover, drain the oil, get replacement filter, and report low filter quality to the manager. Fill up oil and put the cover back. When the oil change is complete, a supervisor issues a bill, gives it to the customer, and keeps a copy for a manager. The customer makes a payment and then drives out the dock. PMBOK is a tabular form of process analysis. It also has some additional information about the process. It is reasonably straightforward, so please download the project from the materials attached to this course and review it as an exercise. After collecting cycle times and reviewing the process, we can identify the waste easily. And in this case, we have first, waiting of the customer and the supervisor. Second, transportation waste type, when technician has to walk and get the filters. Third, motion, going to stock room and checking the stock. We will use Excel data analysis tool to do the descriptive statistics and the histogram analysis. From the first histogram, we can clearly see that the distribution is bimodal. Our median oil change time is 8.5 minutes, and the deviation is 3.4 minutes. When we see bimodal distribution, we should always ask a question: what is the cause of it? In this specific example, the data contain measurements taken during 2 consecutive days. I went and talked to the manager and asked him questions, and I found out that there were 2 different technicians working those days, and also the second technician is less experienced. When I broke down data by a technician, the picture has changed. Technician 1 is experienced technician and changes oil in 7 minutes plus minus 2 minutes. Technician 2 is untrained, and standard deviation is 3.5 and median time is 11 minutes. Also, you can see that the distribution for Tech 2 looks a little bit like bimodal. When I started digging and asking more questions, I found out that the less experienced technician has difficulties servicing cars that he has not worked on before and needs to review the manuals and ask supervisor for help. As you can see, histogram and statistical analysis is a very powerful tool at your service. Based on our observations, measurements, and analysis, we can recommend the following: train employees, automate check-in, automate stock reporting, drive customers' cars in a dock, automate stock ordering, rearrange locations of tools, relocate filters closer to the tech. So now we need to do effort and impact matrix analysis. When we classified recommendations, we can see that training technician is the best first step toward process optimization. And high-effort solutions might be considered in the future as well. However, high-effort and low-impact solution is definitely out of the picture.